Step 5.5, data structure analysis. We want to now look at segment level stability analysis, and we want to look at it at across solutions. So if we want to calculate it across solutions, what we need is a sequence of partitionings with different number of segments, and we'll be reusing results we've already calculated for segment level stability within solutions. We're using object here created on the artificial data set with 3 clusters using step CC cluster with the number of segments between 3 and 8, 10 random initializations used for each k-means solution for number of segments. And then the crucial step is the renumbering. So we need to relabel it, to renumber the sequence such that the numbers align and we can easily plot them. We're using this solution here after relabeling, and then we're using the solution on the vacation motifs used here, also generated with step CC class, but a different method for finding the partition is used. And the result can be directly calculated and plotted using function SLSA plot. That's segment level stability across solutions plot. And we're changing the margins, so we want to have less margins. And then we plot the result for the sequence of partitions for the data set which contains true segment number 3. So here we have the 3 segments. Here we have 8 segments. And we see how do the consumers assigned to each of these segments, how do they move between the segmentation solutions with different number of segments. So we see here in segment 3, all consumers are here in segment 4 in the 4-segment solution. They are all in segment 5 in the 5-segment solution, and so on and so forth. So we see segment 3 across all solutions is extremely stable. All consumers are always in this last segment. And we also see how relabeling was successful in having this always at the bottom, that segment which contains the same consumers in each of the segmentation solutions. Segment 2 also stays the same when we go from segment solution with 3 segments to a solution with 4 segments, but you also see that segment 1 here is split into 2. Starting from the 4-segment solution on, we have a coloring of the nodes indicating the stability index. So for the solution to the left, we cannot calculate the stability index because there's no solution before, because we're calculating the color here depending on how many branches and how thick are each of them go into this point, because here there's just one branch going into it. It has the highest stability, is fully green. Whereas here this point 5, it has 2 branches coming in, and also the second one has sort of a substantial size, so this is less green because it's a less stable segment. And in the same way we can calculate the plot for the vacation motif dataset. Again, here we have the 3-segment solution, 8-segment solution, the gray points here because we couldn't calculate stability, but then we see how stable segments here are over time. We see segment 1 here, and that solution is the most stable across all of these solutions, whereas for example here segment 2 gets split up into 2 from the 3 to the 4-segment solution. Here we have a very gray point because segment 3 receives segment members from the 3-segment solution from segment 1, 2, and 3.